The next presentation is on the Japanese Railways past, present and future by Dr. Toshiji Takatsu is a consultant with the GIC Japan. The moderator for this session is our president, Mr. Vinu Mathur, who is an active president of the Rail Enthusiast Society. He has been a railwayman all his life and he retired as a member of the railway board. His love for the railways is evident from his book, The Bridges, Buildings and Black Beauties of Northern Railway, which he authored and is now working on his next book on rail architecture. I would now hand over the session to Sri Mathur to take on further because we're running out of time. Thank you, sir.
Thank you, Manoj. I'd like to welcome Dr. Toshiji Takatsu and apologize to him for starting late. The Japanese are very particular about punctuality. So I'm sorry we got delayed a little because of a glitch in the Wi-Fi in a particular area of India. Let me introduce Dr. Takatsu. Dr. Takatsu was educated at the Hokkaido University, from where he passed out in 1972. In 2006, he later also got his doctorate from the same university. He joined Japanese Railway through a very elaborate privatization process. He has he then, after working in the JNR, he joined for some time in 1987 the Japanese Railway Construction Company. He has had a stint with SCAP in their land transport department in the early 90s. And he has spent most of his career on an organization which is known as JRTT. JRTT is the organization which does the construction of all high-speed railway lines in Japan. So Dr. Takatsu is really an expert in railway construction. Japan has a very interesting arrangement, whereas this sort of government-controlled agency, JRTT, does the construction of the high-speed railway lines. They then lease these lines to private operators who actually run trains on the lines. In JRTT, he rose to, he was the head of the Tokyo Bureau. He was advisor to the president of the organization and was finally executive director in JRTT. In 2012, he joined JIC, which is the consultancy wing of the JR East Railway Company. He became its executive vice president and was then came to India in 2013 as the team leader for the India project, where they first carried out a joint feasibility study with the Indians. He then was involved in follow-up studies and finally the detailed design for the project once the project was approved. He is, because I witnessed him as the head of the India office. What is remarkable in Japanese consultancy groups is that they are not people from one organization. They draw in experts from a large number of entities within Japan. And he very ably and competently managed this entire team of Indians as well as Japanese experts. He's an extremely soft-spoken individual and professionally very competent in his field of consultancy and civil engineering. He will be making a very interesting presentation to us on the sort of transformation of the Japanese railway, starting from the very beginning, coming to the stage where it got privatized, the first bullet train in Japan, and the changes that have taken place since and what we are expecting in the future. I now hand over the session to Dr. Takatsu. Dr. Takatsu, you can share your screen with us and make your presentation.
Good afternoon, everybody. Thank you very much. Very kind introduction. I'm very happy to be here and make presentation. Today's topic is Japanese railway, past and present and future. The content is my personal opinion, not company's states. This is the content of my presentation. First, development of railway network past and Japanese railway at present, and third, Japanese railway in future, and conclusion. This year marks the 15th anniversary of Japanese railway. That is 19 years after Indian Railway. Indian Railway is an elderly brother in Asian country. The first railway line in Japan opened between Shimbashi and Yokohama in 1870 using narrow gauge of 1067 millimeter. I would like to introduce two engineers who contribute in the early stage of Japanese railway. One gentleman, his name Edmond Morel. He's a British railway engineer. He came to Japan on 1870 as a chief engineer. He had experience in Australia and New Zealand. So I think from his experience, he proposed narrow gauge for Japanese railway. At that time, Japanese officer didn't understand the meaning of gauge very much, and it was decided without not much discussion. He understood the Japanese situation well and gave appropriate advice and guidance, such as adapting wooden sleeper instead of steel sleeper and developing training school for Japanese engineer. Unfortunately, he had sick and passed away on 1871 before opening the railway. The grave is located in Yokohama, and even now, Japanese railway officer visit with gratitude every year. And left side, another engineer, he's Japanese. His name is Inoue Masaru. He's called the father of Japanese railway. He went to England in 1863 and studied railway engineer in London for 5 years. At that time, Japan was closed to foreign country and could not go abroad. He broke the rule of national isolation. He returned to Japan in 1868 when Edo shogunate ended in Japan and a new government was born. Then he was in charge rail chief executive officer for a long period until he retired in 1893. He was so active in various fields such as expanding railway line, creating master plan, and especially developing human resources. First, railway was built by Japanese government in public. Railway network has expanded step by step. With financial difficulty, it was promoted in combination with private company and public national railway. In 1892, the Railway Construction Act was decided, blueprint for national-wide railway network in Japan. And 1906, the National Railway Nationalization Act was decided. The government purchased 4,800 kilometers in total length of local private trunk line. And 1920, the Ministry Railway was established And after World War II, the Japanese National Railway was established as public corporation. And then in 1987, JNR divided and privatized. Next topic is gauge. As I said, all main lines in Japan were built by narrow gauge, but there are several big debates on issue of gauge in Japan. Blue train plan, standard gauge high-speed train project, were carried out from 1940 to 1942. Land acquisition and long tunnel construction started, but because of the war, the project was stopped. This photo shows a model of blue train set. Of course, at that time, it was planned by steam locomotive. And then Tokaido Shinkansen opened in 1964. As you know, that was the first high-speed railway in the world. Among several options, it was finally decided to build a standard gauge line completely separate from the existing narrow gauge network. The initial speed was 210 km/h. This is Fuji Mountain and Shinkansen. I would like to introduce Sogo Shinji. Sogo Shinji was a railway officer born in 1884 and was involved in the standard gauge high-speed railway project when he was young. In 1955, at the age of 71, he became fourth president of JNR. He made a big effort to construct the standard gauge high-speed railway. That was his dream. He's called the father of Shinkansen. Because of the financial difficulty at that time, he borrowed the money from the bank. I would like to explain main characteristics of Shinkansen. First, high speed, maximum commercial speed 320, now 350 under planning. High capacity 15 train per hour, 1,634 maximum passenger per train. Zero fatality since opening, and countermeasure against disasters such as earthquake, strong wind, heavy rainfall, etc. And punctual average delay less than 1 minute per train, and environmentally friendly, less CO2 emission, countermeasure against noise. This slide shows the operational range of each JR company. As you are aware, Japan consists 4 main islands: Honshu, Hokkaido, Kyushu, and Shikoku. JR East covering east side of Honshu, including a Tokyo metropolitan area. JR Central covering a central part of Honshu, including a Nagoya metropolitan area, and also operating a Tokaido Shinkansen. West Japan covering a west side of Honshu, including Osaka metropolitan area. JR Hokkaido, JR Kyushu, JR Shikoku, covering each island. But the Japan Freight Railway Company, not divided, its cover for Japan. Seikan Tunnel. The tunnel was the first undersea tunnel between Hokkaido and the Honshu main island, length 85 kilometers in 1988. The technology was used in construction the Eurotunnel between UK and France. And this slide shows the Honshu-Shikoku Bridge. This is a double-deck bridge. Upper level is using for highway and lower level is for railway. It was completed in 1988, connecting Honshu and Shikoku. Next, I will explain the Japanese railway as a present. Japanese railway play a major role, mainly in passenger transport. In the freight, only 5% Tokyo base because of coastal shipping is sharing 44%. High transport density, comparatively high share of transport volume passenger, many enterprise of various types from public to private body, about 200 railway organizations. Business activity of private railways are characteristic. This slide shows a business model of private railway in Japan. Development of suburban area by constructing new railway, large-scale housing development of corridor type, development of urban terminal station, including a construction department store and hotels, through operation with subway line. We call this model as TOD, transit-oriented development. This is some example of newly constructed suburban railway line, Tsukuba Express. This is a JR line, Joban line. Originally, it was planned by JNR as a increase the capacity of existing line, but because of the JR had cannot make a risk project, so it was decided like a PPP project, some coordination between central government and local government and private sector. It was so successful, open in 2005. And this slide shows the framework for implementation of Shinkansen project after JNR privatization. JRTT, government agency, Japan Railway Construction Transport Technology Agency, infrastructure construction and ownership. JR private company, they are owning rolling stock of Shinkansen and operating a Shinkansen. They are paying a lease fee within the benefit of operating Shinkansen. We call separation of operation and infrastructure. This slide shows Shinkansen under construction. Blue line is the operating line. Now, red line is under constructing. Kyushu Shinkansen from Takeo Onsen to Nagasaki will open this year, September. And next year, Hokuriku Shinkansen from Kanazawa to Tsuruga will be opened. And Hokkaido Shinkansen 2030 from Shin Hakodate to Sapporo will be opened. This slide shows a second tunnel dual gauge. The tunnel was designed, constructed to serve both conventional train and Shinkansen line, lining a third rail. This is a common rail. This is a rail for narrow gauge. This is rail for standard gauge. Currently, Shinkansen express trains are operating in maximum speed 160 km per hour, and freight train are under 110. So Shinkansen and freight train can operate within the same tunnel. This slide shows the share of non-fare box. In In addition to transport operation, non-fare box such as retail and service and real estate and hotel, etc. This fare is very important for railway company. For example, JR East Group, 32% is non-fare box. Surprisingly enough, Tokyo Group is a big railway private company. 82% is non-fare box. This slide shows the Tokyo Station City. This is a railway including Shinkansen and conventional line. And this is a Marunouchi side, Imperial side. This old brick station was restored.
Five Nights at Freddy's is that's where I want to be. I just
and opposite
this
side,
is where you
3 high-rise buildings were constructed for commercial and
I'm sorry.
Bitch, shut the fuck up.
Shut the fuck up, you nasty bitch. I don't know how to fuck you.
and also inside station
hello. Please help me.
some
Here too much raining.
commercial purpose. This slide shows a rail business inside the station. Eco Ekinaka. Same as department store, main restaurant, the shopping store, and the conference room. This is a Kyoto Station. Under the big dome, there are complex theater and hotel and shopping center. Of course, a rail service function. Japanese railway in future. First, sustainable railway management. With COVID-19, the railway are facing a major challenge such as reduced transport volume and revenue. 35 years have passed since privatization in 1987. The system and mechanism of railway management and development should be reviewed. In particular, it is necessary to examine public support measures for a local line with low transport volume. This slide shows the JR East business model. Of course, the transport service is the most important item. In addition to transport service, IT and Suica service, and also lifestyle service combined, and creating new value, realizing overall optimization of the whole.
Hello.
Second, technology development. Various technological development have been implementing, such as safety management, service improvement, speed increase, maintenance technology, disaster management, environmental and energy measures. JR East started hydrogen fuel cell train test run. And also by JR Central, superconducting magnetic levitation MAGLEV system is under construction between Tokyo and Nagoya. This slide shows a Yamanashi test track, MAGLEV. It ran 500 km/h. This is a mechanism of MAGLEV. Previous motor like this, and linear motor in a guideway, levitation coil and propulsion coil will be installed both sides. And also superconducting coil will be installed to the rolling stock separately. So magnetic force, for example, S&S, N&S, repair, levitation. So 10 centimeter levitation will be by magnetic force. And N&S attract, it will be a force of propulsion. So by the magnetic force, rolling stock will moved. So there is no rail and wheel. and also no pantograph and catenary. So it means very few maintenance costs and noise will be reduced. This is a history of MAGLEV. General started technological development in 1962, very old. In 1977, the test line was established in Miyazaki Prefecture. At that time, the T-style guideway, not U-style, record maximum speed of 517 kilometers, unmanned driving in 1979. Yamanashi test track, the length is 42 kilometers and slope is 40 per mile.
Oh!
The maximum radius is 8,000 kilometers. And test run started in 1997. In 2003, it set the world's record of 581 kilometers for manned driving. In 2015, 603 kilometers per hour recorded. In 2014, the construction of the MAGLEV line in Tokyo and Nagoya began. This slide shows the MAGLEV line. This is the Tokaido Shinkansen. Because of the capacity of Tokaido Shinkansen almost limited, and also the big earthquake were expected in a coastal area. So the MAGLEV line planned almost straight in a mountain area. From Tokyo to Nagoya is now under constructing, and from Nagoya to Osaka is under planning. As I said, test track, 42-kilometer test track is completed, and it will be utilized after completion for line. This slide shows the economic impact of MAGLEV. Before MAGLEV, it will take about 1.5 hours from Tokyo to Nagoya. After MAGLEV, it will reduce only 40 minutes. So this scale circle shows some economic scales. So after MAGLEV, big mega economic zone will be created. So it means a big influence to the people's life and economy, Japanese economy. So third, international cooperation. Many international cooperation projects in the field of railway are being implemented in public-private cooperation. This slide shows the only high-speed railway, but also the many urban transport projects are also going on. Among them, Mumbai Ahmedabad high-speed railway project is a priority project and biggest project. Yesterday, I had a presentation, Mr. Achakare's presentation. I impressed very much. I hope project will be successful and between the, this project is a symbolic project between India and Japan. Conclusion. This year marks 150th anniversary of Japanese railway. Railway network has been expanded, contributing Japan's economic development and the importance of welfare of people's lives. The Tokaido Shinkansen opened in 1964, bringing a new transformation for high-speed railway era. With COVID-19, railway facing a major challenges such as reduced transport volume and revenue. The system and mechanism of railway management and development should be reviewed, including the role of public sector. Various technology development,
Shut the fuck up!
MAGLEV have been implemented for future innovation. Many international cooperation in the field of railway are being implemented in public-private cooperation. As the information and digitalization revolution are progressing, the convenient and smooth movement of people and goods is indispensable. As a railway system is energy saving, environmental friendly mode, we have to contribute to the world through further technological innovation. It is important for railway and the railway industry of each country to deepen cooperation. Thank you very much for your attention. This is the last of my presentation.
Thank you, Dr. Takatsu, for a very enlightening and very informative presentation. I'm sorry there were some disturbances in between because a lot of mischievous people were trying to get in. So now let's come to some questions. Do we expect any further upgradation in the Japanese HSR Shinkansen technology? I mean, I know we are going on to MAGLEV, but you mentioned that the speed is likely to go up from 320 to 350 kilometers per hour. So what are the changes in technology that we expect that will take place within Shinkansen?
Yes, I think one category is a speed up. As I explained, Hokkaido Shinkansen will be complete coming 2030, but the distance from Tokyo to Sapporo is rather long. To compete airplane, we have to.
Hi, Val. Nice to meet you.
We have to increase speed.
What the fuck is going on?
And then save a time. So JR East has now continuing some test run by some technical improvement. Noise issue is a very big issue for speed up. So including environmental issue, they are making effort to speed. And also another issue is service level. Now, originally Shinkansen had service only passenger, but nowadays some trying to carrying a small weight by Shinkansen using some capacity of. So that could be some initiative.
Yeah, thank you. Let me see whether on chat some questions have come.
So in the meantime, apologies for the unwanted people who are joining in. I'm trying to remove them as they are coming. But
thank you.
I'm very sorry.
There are a lot of mischievous people.
Can they be permanently blocked?
Yes, sir, they are blocked from Zoom, so don't worry about it. But there's a team of them. Yes, sir.
Another noteworthy, this is particularly for the participants, the point that was made, and it also applies to India, is regarding, augmenting of revenue, because in passenger traffic, revenue is a major issue. And the revenue that we are getting out of in Japan, as you said, 32% of revenue comes from the non-fare box revenue. So how did you develop specialization with respect to these aspects of retail and tourism and hotels and so on? Because that is really a very big achievement of the Japanese railway.
Yeah, that's right. And during the Japanese National Railway period, it was controlled by the government to prevent another to join another part of the activity. But after general privatization, JR made a big effort. So especially Suica, that's a smart card for ticketing. It's very convenient. Only one touch, you can enter within the station, and also we can buy many goods in the shop, not only inside railway station, but also the outside the station and restaurant. We can use a restaurant. It is very convenient, and that could be very big business. And also JR can collect many data, big data, some activity of people, and so that could contribute to analyze for future strategy and some plan. That could be a very good asset. I think so.
One question that has come on the chat box is, can you tell us something about the work culture on the railways? It's a very interesting aspect of sort of how do you build a effective work culture within the organization.
Yeah, that's I think I worked United Nations ESCAP, and I visited many railway, and also I visited Ministry of Railway of India, and also Western Railway and Central Railway, and I felt railwayman philosophy is almost same, and culture is a little bit different, but safety and for the society, that philosophy, railwayman philosophy is very common, and we are as a family. And
okay, there's another question. How does the cost compare of MAGLEV, construction cost of MAGLEV as compared with
high speed?
And with high speed?
Yeah, I'm not sure, but cost of MAGLEV is very high.
Much higher.
Yeah, compared with Shinkansen. Of course, mass product effect will be considered, including technology development cost should be included in cost of MAGLEV. But now they are only Tokaido bypass line is under planning. So I'm not sure what cost is now, but I'm sure it's
okay. Another question that has been asked is, how do you regulate shoppers? You know, you have big marketing complexes at your stations, particularly at Tokyo. Below, there are a large number of shops, and retail is an important business segment of the railway. So how do you regulate that, the shopper, the traffic, so that it does not interfere with railway operations? That is the question.
Yeah, at the beginning, there was such an opinion, but in the planning stage, we planned some separation of zoning inside of station, some shopping zone, and also the railway service zone. So I think plus effect is coming. People coming to shopping by using a rail. For example, some test the cake could be only purchased by Tokyo Station. In such case, some person can buy.
I think the person who has asked this question, Mr. Sharat, if you look at Tokyo Station, they are the shopping area and the train operation area are separate levels, so they don't interfere with each other.
Yeah, that's right.
Right. So, Dr. Takatsu, thank you very much for a most interesting talk. The high-speed rail or the Shinkansen or bullet trains in Japan are a part of Japanese culture. They have contributed so much to society, and every child in Japan looks up to the Shinkansen. We hope we will be able to transfer that level of technology and interest to India, and we would like to see transformation that comes from high-speed rail to India also. Thank you very, very much.
Thank you very much. Thank you very much.
Thank you.
Thank you, Vinu sir.
Manoj, all yours.
Yeah, thank you, Vinu sir. Thank you, Mr. Takatsu, Dr. Takatsu.
Thank you.
Presentation. I think all of us have enjoyed it and learned a lot about Japan and the Japanese railways.